Hi! In this fourth mini video, I will provide you some information to be able to answer to question number 4 of the game, How does our planet work? Climates. Here is Hélène Gaonac'h. Question number 4 is, what is the Vostok ice score? But before talking about Vostok, scientists can look to the past several centuries and millennia for information about the climate of the Earth through historical archives. For example, in ancient texts or with paintings, such as this one from Peter Bruegel the Elder, exhibiting a cold winter in 1565 in Belgium. This cold climate was present in Europe and North America between the 14th and the 19th century. Trees are also enable scientists to identify annual climatic variations using tree rings. A tree grows by producing lighter tree rings during the active growth period and darker rings during autumn and winter. Characteristics of a ring, for example its thickness, will be influenced by weather conditions, therefore by climatic conditions, over many years. For example, the quantity of rain, air temperature, the length of sunshine, etc. By dating the tree rings, scientists can then interpret the variations in chemistry, in texture, as being related to climatic variations. To get information on older climates, scientists can use ice cores. These cores are collected in polar regions, in Greenland or Antarctica. Scientists will collect the ice core by drilling through ice sheets. Here is an example of a piece of ice core. Scientists will find in it climatic information by studying ashes, ice crystals, or gas bubbles trapped in the core. Scientists also have other sources of information, such as fossils or microfossils, that did develop under peculiar climates. Microfossils are observed with a microscope. On the image are foraminifera, unicellular marine animals having an external calcareous shell called a test. These ones have been found at the surface of warm oceanic waters under warm climates. Scientists will also find sediments as a series of coal layers. They will date these layers that form under humid and warm climates. Carbonate precipitates from stalagmites found in caves also help them understand more about the Earth's past climate. Pollen, with its hard external shell, can stay intact for thousands of years at the bottom of lakes and rivers and allow us to identify plants that live there. So, identifying the pollen will explain what vegetation was present in the region during a peculiar time. With the information, scientists are able to study the past climate of the Earth, and they have noticed that it changed regularly and many times. They studied these changes. Many causes explain the changes. We have already mentioned some of them, such as the change in the Earth's orbit, the change in the rotation axis angle, variations in solar activity, appearance of volcanic eruptions. We can add the change in composition of gases and aerosols during the Earth's history, the consequences of tectonic plates, which play a significant role on the Earth's climate by modifying, for example, the shape of oceans and by moving continents at other latitudes. Collisions with asteroids can also be mentioned, since such events transform the soil, the atmosphere, the stratosphere. One interesting source for climate interpretation is ice cores. We will speak here about the Russian ice core from Vostok, well known in the scientific community. This core has been drilled in Antarctica to a depth of more than 3.5 kilometers in 1998. Soviets arrived there in 1957. The deeper the ice, the older it is. Scientists have therefore been able to go back from the surface of the ice core representing today to more than 400,000 years ago. They use the collected data to construct graphs, such as this one. Horizontal axis, called the x-axis, is the time. On the right is today. And on the left is 420,000 years before present. The vertical axis on the left exhibits in dark green the difference from current temperature in Celsius degrees. This means that after a past temperature has been estimated, then the temperature in Antarctica from today is deduced from it. So we observe the difference between the past and the present temperature. Positive values on the graph indicate that the past climate was warmer. Negative values indicate that the past climate was colder. You can also see a lighter green curve with the associated with the vertical axis on the right. It exhibits the variation in CO2 concentration in ppm. Carbon dioxide, CO2, is one of the main greenhouse gases. The unity, ppm, meaning parts per million, is the number of CO2 molecules in 1 million of air molecules. What you can notice is that the two curves are following each other. More precisely, scientists noted that the rise of the temperature appears a few centuries before the rise of the CO2 concentration. They explain it this way. While the average air temperature on the Earth increases, more CO2 is released from the oceans. This is a question of solubility. More CO2 in the atmosphere implies more greenhouse gases in the atmosphere that will in turn provide a rise of the atmospheric temperature, and so on. Then the two effects stimulate each other. This is called a feedback effect. Here is a small anecdote about the Vostok station. A freshwater lake lies under 4,000 meters of ice below the station. This lake has been reached by drilling in 2012. Another story is that this station is the place where the lowest temperature in the world has been recorded, minus 89.2 Celsius degrees. Here at the end of the fourth mini video. You can find all the videos about this climate game on the blog at the address jeuclimat.blogspot.ca. Have a nice day.